Math lesson, week 4, factoring. Today we're going to go over polynomials. There are different types of polynomials. First, what is a polynomial? Polynomial means a many-termed expression. You can see here that the expressions underlined in yellow are terms. Terms are always separated by a plus or minus sign. So you can see that this expression has 4 terms. This expression has only 1 term, and so we can further identify this as a monomial. This expression has 2 terms, so we call that a binomial. Bi stands for 2. And then we have a trinomial here because it has 3 terms. Another special type of polynomial is a quadratic. Quadratic is in this form, ax squared plus bx plus c. There always has to be a number in front of the x squared. In other words, a can never be 0. We have coefficients a and b, and then we have a constant c. So this is an example of a quadratic, 2x squared plus 3x plus 4. We also have an example of a quadratic here, 2x squared minus 2. B is just 0, meaning we don't have a middle term. But since we still have an ax squared, and we also happen to have a constant, then we have a quadratic here. What do these types of polynomials look like? Well, the quadratic we were talking about before is right here. So this is called a parabola. It looks like a U. So quadratics are in the shape of a parabola. The parabola can be facing up or down or to its side, depending on the coefficients. We have a line here, and you can see this function is a polynomial function because we have 2 terms. And x is to the first power, therefore we just have a line. We can also have another type of polynomial function that describes a circle. If we have it in this form, then we can easily identify the center of the circle as h and k, and the radius of the circle as the square root of r squared. So if you have a function in that form, you can automatically graph it. So what is a polynomial again? Any expression with more than 1 term. So let's take a look at the 4 choices below. Which one is not a polynomial? As you can see, each one of these has more than 1 term except for negative 4y. So he is not a polynomial. The name for him is a monomial. Now we're just going to talk briefly about factoring quadratics. If we represented each one of these expressions as an algebra tile, then x squared would be this blue square. Each x is going to be represented by a green rectangle, and then we have 1 as this small chip here. So altogether we have 1x squared plus 2x's plus 1. So we can write that as x squared plus 2x plus 1. What we want to do now when we're factoring is we want to try to move these tiles into the shape of either a rectangle or a square. If you turn it into a square, you have a special type of quadratic that we will talk about later. But for now, let's just imagine moving these tiles around. If we have them cut out on our tables, how would you move them so that they would look like a square? So after you have some time to experiment with that, you may have come up with this. So you can see if we put the x next to our blue square, then we put our 1 here, and then we put our other x tile would fit right there, and you would have another square. Alrighty, so how do we rewrite this as this quadratic after factoring it? So this side of the square is x plus 1 units long. This side of the square is x plus 1 units long. X plus 1 times x plus 1 is equal to x plus 1 quantity squared. So that's equal to this whole entire shape. X plus 1 times x plus 1 will give you the area of a rectangle or a square. So now you can see that we can rewrite this this polynomial as x plus 1 quantity squared. Let's move the other way around and let's go ahead and expand. So we're already given a rectangle. All right, this dimension is x plus 1 units long. This dimension is x plus 2 units long. What is the total area of that rectangle? So you can see we have a purple square here. That's x times x. The area of it is x times x, so we call it x squared. We have 1x squared here. Then we're going to go x times 1, so that gives us a rectangle. X times 1 is just x. Okay, next one here is 1 times x. We get another rectangle the size of x. Another 1 times x. Oh, sorry, I should go in order. So we're going to have 1 times x there, and then 1 times 1 here for 1. Okay, now 1 times x gives us another rectangle of x, and then 1 times 1 here will give us 1. So this is everything that we have when we multiply x plus 2 and x plus 1 together. When we add all three of these, okay, when we write this down, we get x squared plus 3 x's for the red rectangles plus 2 for the green. Okay, so that's just showing you how to expand something. We can also call this method FOIL, which we will talk about next. FOIL, you may have heard before, is first, outer, inner, last. Okay, so then we take the term on the very first term we see reading from left to right, which here is 3z, and we're going to multiply the next first term in the other set of parentheses. So we get 6z squared. Now we're going to stick with 3z here. Now we have to multiply this 3z by the other number inside the second set of parentheses, which gives us 21z. Then now we have to take our inside, multiply those two together, so 5 and 2, and then we have to multiply 5 and 7, so 10z and 35, put them together for 6z squared plus 31z plus 35. Remember, you can combine like terms here. If they're the same variable to the same power, so both of these have an exponent of 1, and the same letter, so we can just add those like regular numbers. So 21 plus 10 is 31, and we have 31z. Okay. This is factoring using the FOIL method, which we will go into here more. But the main thing here is to think about factors of the constant here. So you can also check out factoring using the box method at this website on YouTube. We'll talk more about this method in a minute. Let's talk about factoring special types. So I mentioned earlier, you might have a scenario where you'll recognize a pattern. Okay, First of all, we just want to recognize that it's a polynomial. Second of all, is it factorable? Can we turn it into a rectangle or a square? So the FOIL method of factoring is to think, okay, I don't have the tiles necessarily, and maybe we're not using the box method, but the box and FOIL method are very similar, so we're just going to stick with FOIL for now. Now let's think, what two numbers, when you multiply them together, will give you 12? Okay, so 6 and 2, yes. 4 and 3, yes. Okay, so now we don't want just any two factors of 12. We want two factors whose sum will be this middle term. So 6 plus 2 is 8. That's not 7. 4 plus 3 is 7. So we're going to use those numbers inside our parentheses in these spaces here. We already know the first term. We already know what goes here because this first term is x squared. X times x is x squared. So that one we automatically will know. Okay? So like I said, we're going to turn our blanks into 4 and 3. And now we're going to check it using the box method. So you can see I'm putting x plus 4 here, x plus 3 here, x times x is x squared. X times, so x times x is x squared. Okay, moving this way, we're going to multiply x times 4 here to get 4x. Now I'm going to go down to this row. 3 times x is 3x, and then 3 times 4 is 12. So you can see, when you combine these, you'll get the same thing as before. You'll get x squared plus 4x plus 3x, which is 7x plus 12. Okay. Here we have what's called the difference of squares. So now, if we're given a binomial and you can take the square root of the constant, it's called the difference of squares. It's a binomial, so it has only two terms here. So what we're going to do is we're going to have two opposite signs that basically eliminate our middle term. All right, we stick with x as the first term in each set of parentheses. Trying to move this so you don't automatically. So we're going to use the same method here of, we're going to use the same method. We're going to think of what two numbers times themselves will give us 1, which 1. So the only two factors of 1 are 1 and 1. So we're going to have 1 and 1 there. Now their signs have to be opposite because that middle term has to cancel each other out. So if you use FOIL, you'll see you get x. Or the box method, you get x squared plus x minus x minus 1. These two cancel each other out, or x squared minus 1. One more. Here we have a case where we have to complete the square because there is no perfect rectangle or square that this trinomial describes, so we have to make it into one. This video here, I will give you the link here in a minute, but it shows you how to actually complete the square using the box method. And it's a simple, very simple way of doing it. Not a lot of steps, and I think you'll find it helpful when you are working on problems, including parabolas or circle problems in your classes that require you to complete the square. So I'm going to go ahead and share this link. This will be the end of our lesson today. I hope you guys have a great rest of your afternoon or on Edmodo, completing the quiz. Have a great rest of your day. Talk to you soon. And here's the video. Sorry, here it comes. Sorry guys, here we go. I'll make that bigger. Maybe not. Try this again. That will take you to the actual video if you click on this link. Put it in the chat. Thanks and have a great